Kia ora koutou, welcome. I'm going to kick off our session by introducing our first speaker. But first, I should introduce myself. My name is Gianna Makar. I'm the Communications Manager for New Zealand eScience Infrastructure. And I'm very pleased to welcome up a colleague for the first speaker, Georgina Ray. She is a Science Engagement Manager for NeSI. And she's going to come up and give a lightning talk to kick things off about the Research Software Alliance, ReSA, and NeSI.
Kia ora everyone. Hopefully you are feeling good after that nice lunch. I'm really enjoying the proportion of vegetables in the lunches and was very happy to also find the cake area, which was hidden from me yesterday. So this is a lightning talk, and the reason I've very specifically chosen that format because I really just want to shine a light on the Research Software Alliance. We are here's the punchline. We're a member now, so you can go. No, we're a member, but I wanted to explain a little bit about what does that mean, why would we be a member, and kind of what it can mean for you guys. I think I'm preaching to the converted here, but software matters. And look, a very famous lady has been quoted here, but yeah, go on. Can I get a selfie? So we know that software is absolutely ubiquitous through science and research, and we try and tell funders that, right? Like we can say hand on heart, we feel this passionately, but unless you have a bit more than just that sentence, you're not going to change anything. And the Research Software Alliance was formed or established in 2019 with a bunch of folks who had a vision. It's up here. Research software and those who develop and maintain it are recognised and valued as fundamental and vital to research worldwide. And so this group has taken it upon themselves to make sure that research software is top of mind, that we're thinking about the people, the infrastructure, and the policy. So they do a lot of different work. There's task forces, there's conferences, they run community sessions, all sorts of things, and I'll show you how to find out about it shortly. But I wanted to highlight two of their big successes so far. This is the group that really enabled the Fair for Research software principles to be published. So they worked really deliberately in a really structured way, so they leveraged the Research Data Alliance, working group structures and things, to collaboratively bring together these FAIR principles. There will be a test later on what they are. But what they've followed it up with, and this is the real goal to what they're doing, they've got the principles, but the next problem is always, so what? How do we do that? What does it mean for our organisation? So they start to follow it up with their toolkits, with their frameworks, with their, sharing what other organisations are doing to move it forward. So, for example, here is a self-assessment for fair research software that ARDC and the Netherlands eScience Infrastructure work together on. If you Google that, you'll find it pretty easily. But you can run your software through that and start to baseline. How fair are we? And that's a good starting point. The other big piece of this really is, I think the Research Software Alliance, ReSA, has largely come out of this from a policy perspective. So they're wanting to really change what the funders think, what the people who set policy think and know about research and how research software plays into it. So they've, over the last, I think there's been 2 of these, they run a research funders forum. So it's a place where organisations, so we're talking, ministries, government organisations that fund research software can get together and share ideas, and they have a community around this. In the New Zealand context, NeSI's involved. Now, we're not research funders per se, we're fans and advocates, and we contribute into the community, but the funders in this space are really groups like MB. So we worked with MB and decided, right, we'll have a presence here, and we'll make sure that we're taking New Zealand's perspective into that conversation, but also trying to bring all the learnings back and from that international space. Now, one of the big things they've done here is to do the ADORE declaration. So I forgot to say at the beginning, permission to Google throughout this. I want you engaging with these documents. So open up laptops, open up your phone, put in ADORE declaration, put in FAIR for research software. Anyway, this is a set of 12 recommendations that were drafted at that funders forum in 2022 and then went on to be published, the first version, late last year. It covers these recommendations across research software practice, ecosystem, people, and ethics. And you can sign on to this. So if you are funding software, you can sign up to this declaration to say that this aligns with what you're doing and that you're going to advocate for it. So at NeSI, we were lucky enough to host Michelle Barker, one of the directors of ReSA late last year, and we did a workshop with the NeSI team on what do each of these recommendations actually mean for us as an organisation. So that's pretty powerful. And punchline, there's a toolkit. So how to engage with this community is read those resources, but then dig into their websites because there are lots of resources to help us. So, as I said at the beginning, in the middle of last year, NeSI committed to being a member of the Research Software Alliance, and this really shows our support of this community, ensures its sustainability, and makes sure that we are able to participate in and bring the learnings from that community back into New Zealand. So, now that you've all got your laptops out, you don't. It's remarkable. Usually at conferences, everyone's in their inbox or something. These are the things you must do. So please do go to the Research Software Alliance website and look at their resources section. It is full of gold. So if you've said to someone recently, research software is ubiquitous, and therefore we need to fund it, we need to support it, we need to make it sustainable, that page is full of links to evidence that you can put in front of people. They have a really useful newsletter, so that's the button to look for on their website. Super helpful. That's full of lots of resources, so the new findings, what's happening, where you can engage in this community, and the conversations are all in that newsletter. They have Slack, they have task forces, and then just want to call out that this all complements things like the research software engineers community that we look after in New Zealand and nurture. So these things are not mutually exclusive, but they certainly do overlap and complement each other. So that's another space you can go if you go along to that website to join into that community and start getting washed with all the fabulous information that is around research software. Thank you. Questions?
Any questions for George about NeSI and its relationship with ReSA?
Hi, thanks. It wasn't a question, more of a comment, that you said that you can, if you're a funder, you can sign the ADORE. But also if you're not a funder, but you want to express your support, you can also sign it, and that's important. So Elixir, the research infrastructure for Europe that I'm representing. We've signed in support. We're not a funder, but we've sent a message to say we, as a European network of 23 countries, support this. So I would encourage everybody to get their organisations to support it.
Yeah, awesome. Thanks, Carol. It's good to know.
Great. Thank you, George. All right, next up, I'm pleased to welcome to the stage Katie Hannan and Renee Tyhouse. They're from CSIRO, and they're going to talk about Optimizing Research Data Management, a journey into the unknown.
Hi everyone, thanks for having us here over in New Zealand. My name's Katie Hannan. I was employed as a data librarian. I don't work in the library anymore. I'm thinking of changing my job title. I'm currently the acting team leader for Research Data Services, and this is my colleague Renee Tyhouse.
G'day everybody. I'm the technical lead for our data team at this point in time, because my role evolves. So just to give you a little bit of context, CSIRO is Australia's national science agency. A few, I suppose, key things about us. We engage with about 4,000 different partners throughout industry, government, and that includes nearly 1,600 odd small and medium enterprises. Throughout that, I suppose we're engaged through a little over 500 international customers and collaborations across 69 different countries. Some of the things you might know about CSIRO, a few of our greatest hits, Wi-Fi, AeroGuard, polymer banknotes, to name a few, and some of the latest things that we've been working on around biosecurity threats and like all the way through to the National Bushfire Behavioural Research Laboratory that recently got opened in Canberra as part of a relocation. We tackle this as an organisation through, I suppose, a framework where things are divided up into missions. Our key challenge areas are up there on the screen. I won't go too much into missions in the interest of time. You can read about it later. But some of the things that we have launched, Aqua Watch, drought resilience, getting towards net zero, and things that we're working on pulling together at the moment. There's a lot of stuff around renewable energy and smart energy. There's a big thing about that throughout the organisation. And of course, still furthering Australia's biosecurity. So, back to Katie.
So the thing that we did there is set the scene so you get a little bit of an idea of just the breadth of the research areas that CSIRO covers. So we do possess an extensive repository of research data, spans all of our science business units as we call them, and it's housed in both local and cloud-based storage infrastructure. A significant portion of this data is securely stored on platforms managed by the Information Management and Technology, or IM&T unit, that we are both a part of. And it's evaluated by third-party cybersecurity assessments. However, some of data resides on unassured storage mediums. Some of you might have heard of shadow IT, such as USBs, external hard drives, local hard drives, or even researchers setting up their own NAS systems. So the complexity of managing and comprehending the storage and utilisation of scientific data has posed significant challenges, and the complexity has made it difficult to ascertain compliance with established policies and standards, leading to an elevated risk of data insecurity, accidental data sharing, and potential data loss. So in response to these challenges, CSIRO launched the Science Data Stocktake project in 2021. And the primary objective of this initiative was to optimise research data management processes and to align with the impending Australian government data availability and transparency legislation. So thinking back to this project and the idea of it, was it actually possible? It was big, it was massive, so we realised we just had to start somewhere. So data management processes within CSIRO are fragmented and driven by multiple stakeholders. This has led to the organisation dealing with a high volume of disparate data and several challenges in maintaining it, such as fragmented data ownership, data inconsistencies, data saved in numerous assured and non-assured channels, data duplication. Some of you might see this as being familiar, so legacy data not relevant to current research operations. Misuse and inappropriate treatment and storage of data. And then there's also, as Wallace mentioned earlier, or yesterday, the cost of data storage that is increasing annually. So this project, it's part of a program called the Managed Data Ecosystem. It's a digital transformation program that is providing future-driven data science capabilities, systems and tools to deliver cutting-edge innovation and digital technology to enable CSIRO and our partners to improve our collaboration. The MDE, as we call it, is connecting current and new platforms and improving interoperability between services so you can seamlessly find and work on multiple data sets. Our project is part of this program of work, and we took a three-phase approach to it, collaborating between my team, the Research Data Services, Scientific Computing Platforms, and members of the Data Stewardship Community of Practice. We had a couple of phases. Phase 1, which is analysis into the tools that we already had access to, and the type of metadata that we needed to include in a dashboard. Phase 2 included the design, build and delivery of a dashboard that derives reports based on the metadata information applied to the dataset. And Phase 3, which is where we're at the moment, engagement and consultation with data custodians and research project managers in our business units to discuss the information that we had about their data holdings and assist them to be more sustainable in their storage consumption, reduce duplication, and to determine what could be published to a data repository, such as CSIRO's Data Access Portal, archived or deleted.
Alrighty, so several factors contributed to the successful development and implementation of the dashboard. So these factors revolved around getting a much better understanding of who and how we provisioned storage allocations to the researchers and identifying what metadata was being captured as part of that allocation, if it was part of a project or a business unit or any other sort of storage allocation. And what we found, of course, is that it's not done consistently the same every single time. So depending on where it came in from a request perspective, dependent very much on what kind of allocation the end requester was given. So working out then, based on the various mechanisms, what is the best way to tag that data so that we actually understood who it was for, why it exists, and who to talk to if we're not comfortable with what's being done with it. So just being able to work out where all of those things happened. And of course, as in any large organisation, when there's a change of leadership, there's usually a restructure and a reorganisation, and things change. So different periods of the organisation's life have seen organisational business units come and go, and just being able to tap into some of that legacy knowledge of what existed at that point in time and why a particular allocation had a certain business unit attached to it. So just being able to find out where all that metadata existed, how we could extract that and then add it to our allocations. So we started to build a bigger picture of the underlying environment to be able to build that dashboard on top. So what did we use? We were fortunate we had deployed Starfish for other purposes, and we were able to leverage that tool to give us a bit of that underpinning information. The tagging and the metadata enrichment component of it, we used a Hitachi product called Pentaho, or some people call it Pentaho. I still haven't really clarified how to say it, but I call it Pentaho, so that's how it's going to be. And then to actually be able to consume that information, once it's in Starfish, it needs to be an easy system. And being able to slice and dice so that you can actually interrogate the data set that we're effectively generating, we ended up choosing Power BI because it was already in use in the organisation, and our executive were quite comfortable in navigating that tool. So that gave us the ability to put the information that we wanted to get in front of the executive in a tool that they were familiar with. So digging into those a little bit more, when you look at a storage allocation within Starfish in our environment, that's kind of what you see. You can see up in that top section there a bunch of tags that we've added to those top level folders. And you can see that when we allocate storage, we create a system folder called .metadata, and within that we put in as much of the metadata that we can gather during the provisioning allocation process so that we understand what that allocation's unique identifier is, what things around the project, and what permissions, who's got permissions to it. So then to get those tags into that, we use Pentaho.
Doesn't sound right.
Yeah, I know. It's just all wrong. It's all wrong. Anyway, so within our organisation, we've got a project management system. It's called O2D, Opportunity to Delivery, and our whole organisation is oriented around that. So this is just a sample process where we go through, we query Starfish, say, find me all the metadata folder entries that relate to O2D. And out of that, standardise it, then check to see if it's already been tagged with that. If it hasn't, go tag it. If it has, all good, move on. So that's a very simple process, and that's automated. That runs once or twice a day. And I think there's about 8 processes in total that query various repositories of metadata within our organisation. So it sort of looks a little bit like this when you stitch it together. We've got Starfish that scans our file system to keep track of where stuff is. Pentaho keeps going through and keeping it up to date, and then we have a ETL that optimises the data that we need out of Starfish into something that we can run Power BI over the top in an efficient fashion, because running Power BI over Postgres just wasn't working for us. So this gives us the ability then to start querying based on tags and filtering. So I can give you a bit of a show, an idea of that. So this is the landing page. We called it Swordfish, just because somebody couldn't remember the name Starfish a lot, so that sort of happened. Anyway, so it got called Swordfish, it kind of stuck. We have a landing page that gives us a bit of a spot to go through. So whenever we do an engagement, we are very much looking towards these various tools. So to give you some idea, this is when we start looking into the data. So this gives us an idea of what filters we can apply, whether it's the data's on disk, on tape, whether we've categorised it as scratch or archive, whether it belongs to a certain business unit, whether it belongs to a project, whether it belongs to a research program. We got lots of options in there, and all of that is derived off those tags. So this is a bit of an example. I've dropped it into the IM and T, so our own business unit filter, and it starts to cut down some of those quantities across the top. You start to get an idea of what you can actually see. We can then delve a little bit deeper and go, okay, what does IM and T have on disk? And then you can actually start to have a targeted discussion with the lead of that business unit to say, are you aware that this is the kind of resources you're consuming, and we can see how much of that data lives in the 0 to 12 months. It's a little over 50%. And there's about a little bit under half of the data is living in that 1 to 2 years since it's been last accessed. So that tells us straight away that there's probably a little bit of housekeeping that we should do ourselves. We've also produced a heat map view, and that gives us a really good idea on finding things that haven't been tagged. And I'm desperately running out of time. So, and that's really useful as well, right? Just to be able to go, okay, now we know who we need to, where we actually need to start looking at the data to try and derive who the owner could be. And I'm getting kicked out. There you go. Over to you. So I can talk about this all day.
Yeah, we could. So this is where I come in a little bit more and my team. So understanding more about how researchers were using our storage systems helped us recognise that we had some big gaps in our service delivery, as well as areas for procedural uplift. So using Swordfish, we've had informed conversations with data custodians, and we were able to identify over 2 petabytes of data that was ready for archival, but we had absolutely no process to do so. So that's when we came up with the idea for the CSIRO Data Archive project. It got the green light and is now part of the Managed Data Ecosystem program. The data archive will help us move data from expensive storage to a cheaper option, saving us some serious bucks on top-tier storage in the long run. So we've set up an engagement process for the data stocktake. So we have a couple of priorities that have been established, where we're looking at old and large data that is stored on spinning disk, where we see that as short-term storage, projects that have finished, data holdings that have an admin group with no members, so there's no data custodian, and then data holdings that do not have a data admin or a recognisable dataset name. So we set up an initial pilot engagement using our own IM&T data custodians, or even just data tagged as IM&T, and then we went out to these people and we said to them, how can we expect our researchers to adopt best or better practice for data management if we can't? So that was where we started. And as part of the strategy, we've investigated whether membership in an admin access control group is correlated with being a data custodian. So we've proactively reached out to lots and lots and lots of different people. And then to address some of the established identified gaps, we set up this group called the Data Management Procedures Group, and we've collaborated with other teams within IM&T, such as across records, scientific computing technical solutions, the data storage team, and we're looking at, we've established a comprehensive ReSA matrix outlining the roles and responsibilities of all of our stakeholder groups in the data management process. And then we've been documenting all of these procedures to create a structured framework for efficient and effective data management. We've also noted that one of the things that we saw as missing from my area was that the guidance to delete data from primary storage systems post-publishing to our data repository was implied, not effectively communicated. So we've changed some help guides and documentation and training materials there as well. And so our success stories. We have conducted initially 80 engagements with data custodians, and then we went out to a further 129 consultations with data custodians or project leaders from research business units during 2023. We're starting to better understand how they're using the storage that they have requested. We're feeding that back into IM&T, and we're working on continuous improvement where storage administration needs and retention and disposal needs are met, and an uplift in data management practices. We are also working on supporting CSIRO's transition to a clean energy future, And one of the features of the data stocktake dashboard is an assessment of the energy consumption associated with storage, and this is displayed as carbon emissions on our dashboards as well. So simple actions such as cleaning up redundant files, publishing to a data access portal, and making use of the coming data archive service, those will play a vital role in advancing our commitment to a more sustainable and environmentally conscious research landscape. So our discoveries. We are definitely not alone in this. Other organisations have lots of data that they are also working on managing. We've participated in the National Archives of Australia's Petabyte Plus Special Interest Group. We have discovered things about rotating doors at projects staff. We don't advise you go there. But we also think that it's better to ask forgiveness than get permission when it comes to doing things within your project and what you think is the right direction to go, particularly when you've had 5 solution architects, 3 project managers, and perhaps 2 or 3 business analysts in 2 years. And what's in the future? I have 1,000 more questions for all of our researchers and all of our managers and our senior managers, our data stewards, lots more things we want to find out. We're trying to understand what qualifies as significant science, because according to our retention policy, significant science needs to be kept persistently and permanently, but you can't tell whether it's significant when it's still within your initial 1 year, 2 years, 3 years. So sometimes in some areas it's not significant science until it's 17, 18, 19, 20 years old. So we need that metadata around it. And our next steps, well, AI cannot do this for us. Computers are not solving this for us, and we need our people. There we are. We're around for the rest of the day, all day tomorrow. And if you're anything like me, you probably have 1,000 questions, because my to-do list and your to-do list on this is that long. Thank you for your time.
Thanks. We don't have time for 1,000 questions, but if there is one, we could sneak it in while other people are coming in the back door.
Thank you. Great talk. Did you identify any debris, and have you deleted anything through this?
Yes. And yes.
Well done. Can I ask how much?
You can ask.
I know there was at least an allocation of over 100 terabytes that we didn't need to hold on to any longer. We had a discussion. There's been a few. I don't think the other one from Perth was all that significant in a volume metric perspective, but just the fact that they admitted that it was, if they were ever going to reapproach that particular type of science, they believed that the instrumentation would be better and they would redo everything that they did anyway, so there was actually no value in curating what they had. It was just, let's just get rid of it. We've got our papers. We can redo it again with better instrumentation. And just that acceptance alone was like a big step forward.
And we've found someone in our own area who has, I think, 15% of the data on our systems that he has is duplicated and growing. So I'm working with him gradually. And other things that we discovered were data that was required for IM&T services that were being provided, so it's now tagged with as system and excluded from our reporting. There's been a lot. We've used CSIROpedia to understand some of the historical research areas so that we can give it tagging. I mean, some of it's been around for...
We have a persistent file system that's about 31 or 32 years old now. So it's been through 5 different pieces of infrastructure underneath, but it is still fundamentally the same file system. And it is organised by individual. So needless to say, there is a proportion of that that is undiscoverable.
Yeah.
So
and
lots of
that's
work
on the
to be
list.
done there, I guess.
We're in the
Yeah.
40, 50 something petabytes
Yep.
area. Thank you.
Thank you. Yeah, good luck with your voyage into the unknown there. All right, our last presentation before the mini break is applying large language models to data-driven research platforms. And I'm pleased to welcome Richard Sinnott from the University of Melbourne and a guest presenter with him.
Okay, I'm Richard Sinnott. I wrote a paper based on, or the abstract based on work that Luca did. I thought it'd be nice to bring him along. This is Luca Morandini. He's going to give the talk.
Sorry. Sorry, you wanted him and got me instead. That's unfortunate. Okay, without further ado, so we'd like to talk here about the our experience at the eResearch, Melbourne eResearch group of the Faculty of Engineering and IT and the University of Melbourne with large language models. So first, why we chose to deploy an LLM on our private cloud infrastructure and not use the OpenAI API, for instance. And then to applications. More the applications, they are proof of concepts, rather. So one applying an LLM to metadata database queries. Another one doing the automated language review, so literature review. So why we chose to deploy an LLM? So we tried OpenAI API as soon as it came out. And we started finding issues. So it was far from being perfect. I mean, my knowledge is like a few months old now, probably has improved in the meantime. But still, despite using the function calling feature, for instance, which is supposed to spit out JSON, it didn't. Well, sometimes it didn't. Sometimes it did, sometimes it didn't. So you need to do repeated requests, just the same request repeated. Sometimes even the JSON was well formed, but contained garbage. There were many failed requests, timeouts, all sort of stuff. And moreover, there is intrinsic fuzziness over LLMs. So if you ask the same question in different sessions to an LLM, you get slightly different answers. Sometimes you get very different answers. So in order to have an answer, we had to repeat the process many times, even if everything else worked. So, and when we applied to a corpus of like 13,000 tweets, then clearly all the requests started to pile up in terms of monetary terms. So, moreover, so there was an interest in just deploying an LLM on our cloud infrastructure. Moreover, there was the idea of opening up to other researchers in the faculty. So, and this is what we did. So the good guys at the RDC provided a VM, a large VM, with 240 gigs of RAM, but especially an NVIDIA GPU, an A100, with 80 gigs of video RAM. So we deployed Llama, an open source large language model, Llama 2, chat version, obviously, with 70 billion parameters, which as far as I know is the biggest. Then we used Llama CCP and Llama CCP Python to replicate basically the base OpenAI API. But then we wanted to open to the world, so we had to develop a proxy server for it. So to queue requests, because sometimes those requests take long, like seconds, tens of seconds. So you want to have a queuing system to put them in order, so not to overcome the LLM. Then we had to handle authentication. so which we did with the GitLab token service provided by our University of Melbourne. Then we wanted to avoid researchers hugging resources, so we implemented rate limiting in the proxy server. And our idea was to use different models in the backend, different models or just different replicas of the same model to speed up things. That didn't go down well, but more on it later. Then we developed a chatbot user interface that uses the API just to give researchers a bit of interactivity, and sort of to debug their requests in an easy way. And then we, of course, deployed Elasticsearch for login and system monitoring. So we call the whole ensemble Calliope, which was the Greek muse of eloquence, which makes sense for an LLM. So basically, Calliope is an API modeled after the base OpenAI API, a UI, a chatbot, basically, and an authentication system, so you basically have to ask us for a key to enter in order to have access to it. So what did we learn? Okay, from this experience, LLMs use a lot of resources. So the crucial bit was the amount of video RAM. So we tried with two models, so two 70 billion parameter models at the same time on the same machine. That didn't work. Okay, the whole thing fell apart and started to time out and stuff. So we now have the back end is just one model. So the whole system was low, but remarkably stable, probably because of the queuing system. So anyway, that's good. And of course, it was free of charge, at least for us. So still we had the same problem that we encountered with the ChatGPT. So sometimes, no matter how you try to force the LLM to give you JSON, it simply doesn't. Or sometimes it's simply not, the content is valid, well-formed JSON, but the answer is not valid. And of course, you have to repeat it many times to have a distribution of answers, and then you through a process called decoding to get the answers that you want, the correct answer, say, usually. So a consensus must be reached. So first application we tried on was with the system, with Special Urban Data Observatory, which is a system of ours that allow researchers to find and analyze, map, chart, do some statistical analysis on data sets about built-up areas in Australia. So we accumulated 8,000 data sets, different data sets, and there is, of course, a metadata database to allow users to browse through them. And on the left, you see the current dataset browser dialog. Basically, you enter a list of keywords, a bounding box, because all these data are geolocated, and you enter a time frame, and then some data sets are selected, and you refine this process. It's a bit clunky. We never really liked it, so we thought to give LLM a spin. So the idea was we take a request from the user in natural language, in English. We tried different languages, kind of works. And then split the request into 3 domains. So the topic, space, and time. Then we ask, so this is the first task of the LLM. Then for each of those domains, we ask the LLM to come out with numbers, with parameters. A list of keywords, coordinates, and starting and end date of the data set that the query refers to. So, and then we converted that into using a program, so not an LLM in this case, run-of-the-mill JavaScript, to convert those parameters into a Lucene query that then is fed into the CouchDB database that holds the metadata. The results are mixed. It is slow, and definitely not ready for prime time, but sometimes it gives you good results, like in this case. So the query from the user was, select data sets about respiratory illnesses in the southeastern corner of Australia in the 5 years prior to the Black Summer bushfire season. These are the results. So southeastern corner of Australia, kind of get it. 5 years prior to 2019, okay. And the keyword, so the topic was respiratory illnesses, was expanded. This is the interfaces we use for debugging. So you see pneumonia was expanded in pneumonia, asthma, emphysema, and all sorts of illnesses. And based on that, query was sent to the metadata database, and then some data sets are returned. So sometimes, often the results are good. The second proof of concept was about doing automated literature review, so using LLM to read scientific papers for us. It started with a niche, basically, because I read an article on The Age, and it was about hunter-gatherer societies, and the thesis of the article was that it's not true that it was men that mainly hunted and women gathered. Women hunted more or less as much as men. This looked to me like an extraordinary claim, so must be backed by extraordinary proof. So, and then I found out that it referred to this article over here. So from PLOS ONE, and all the references were there, and the authors were kind enough to give access to the data set. Basically, this data set was for every of these society, there was all the references, and there were questions that they asked to the people that did the literature review. So, do women hunt in this specific society, hunter-gatherer society? Or is the hunt done with dogs? These sort of questions. By the way, there is a rebuttal of this article, the articles on PLOS ONE, done by the University of Calgary, a group at the University of Calgary in Canada. So I was intrigued by the whole thing. So I asked the Calliope to do it for me. So first I had to enlarge the context windows in order to fit an article or a relevant portion of an article in it. So then I had to prepare the corpus, just convert from PDF to text and do other boring stuff. And then I started to ask the LLM about the questions that were asked to the literary reviewers. And then I compared, my idea was to compare the answers by the LLM with the answers in the original article. I would have liked to, my idea was to use the article as a ground truth. So is it current state of the art LLM be able to do this or not? So, okay, I'll spare you all the nitty-gritty, all the details, but basically I developed a software that uses a template for expressing these sort of questions to an LLM. And as you may, this is kind of chain of thought idea. Basically, you explain all the steps that it has to do, and quite a few of the instructions deal with the output, because I wanted to have a usable output, so on how to produce correct JSON and with the correct data in it. So, and then, as I mentioned, you need really a distribution of answers before getting anything useful out of it. So the idea was to reach a quorum. So you had minimal sample size. So the minimum number of questions were asked, so the same question, the same article, were repeated. If a consensus was reached, the computation stopped there. If not, more questions were asked. So the same question over and over again until a maximum number. So in this particular run of this part, for this particular text, which is there, which is an article, one of the references, The quorum was reached in just 10 iterations. So the consensus answer was 1 in this case. Okay, so the initial results was, okay, first I had to cut down the corpus of reference from 43 to 21. Some of them were just too complex, so they were entire books, so I had no time for it. So anyway, for 21 text, every question took between 1 and 2 hours of compute time. So it was a bit ponderous. So, and I found out that some of the questions, so some of the answers from LLM were in line with the article. Some were not. That really intrigued me. So what I did is I started reading the articles myself because I wanted to see, okay, what's the truth, right? Now, apart from the boring fact that I had to go through all those anthropological articles, I found out that it was more in line with the large language model findings that with the original article author's findings, okay? So in the crucial questions of do women hunt in this particular hunter-gatherer society, in this particular, as written in this particular article, I found out that 95% of the time, my understanding was the same as the large language model. When I compared my findings, I'm not an anthropologist, of course, but my reading, okay, with the ones of the original paper, then it basically dropped to 50%, okay? So I'm in accordance with Llama, with the large language model, and not in accordance with the original of those papers, which means that either they were biased, okay, or me and Llama are both wrong. So I don't know the answer. These are preliminary results, so don't shoot me on this. But my hunch is that LLMs can be used to overcome the bias of literature reviewers. That will be all, if you have questions.
Did you tell the original authors your findings and you refute their work?
No. I mean, it could become a paper, but I'll need more time and resources to do it, to do anything serious, really. This was just almost just a pure concept, almost for fun.
Any other questions?
Any plans to make your experiment faster?
Well, yes, but only if we could, okay, either use a different model, so a model with is smaller with less parameters, and there are some which could fit the bill, so they can fit more in the same machine, or use different machines. But that's restricted because those VMs with large GPUs are restricted, so you cannot have it for more than 28 days so yeah, there's some restriction in terms of resources, but yeah, that's the idea.
Great, thank you very much.
No worries.
Thank you, Luca.